Hello, students, and welcome to another sixth grade math episode with me, your host, Mr. Nerlich. So for today, we're going to be working on lesson 4.2. And lesson 4.2 is dividing fractions. So when you divide fractions, you multiply the dividend by the reciprocal of the divisor. You multiply the dividend by the reciprocal of the divisor. Okay, and now our dividend is a number or fraction you are dividing. And our divisor is the number or fraction you are dividing by. And then we have the reciprocal, which is two numbers or fractions whose product is 1. All right. Now I know this is some bigger, vocabulary, but a lot of this you should have seen in 5th grade or even 4th grade. So this should be reviewed. And it's important you know these words because your math teachers are going to be using these terms when speaking about this kind of content. So you want to understand the vocabulary and know what it means so that when your teachers tell you, did you take the reciprocal before you multiplied, and you might not remember. So then you need to go back in your notes and look up what is the reciprocal or what is my dividend or divisor. All right, let's look at an example. So we have 3/4, and we're going to divide that by 1/2. And on your notes, it's already labeled. The fraction 3/4 is your dividend, and then the fraction 1/2 is your divisor. Your teachers and I won't expect you to obviously label all your problems, but it's good right now as you're learning this to label everything so that you have an idea of what number is what or what fraction is what. And so that way, as you go back and review this, you go, oh, so yeah, that's my divisor. And you can refer to these notes and kind of help you. So then we must take the reciprocal of 1/2. And we know the reciprocal is when two fractions whose product equals 1. So the only way I know how to do it is to simply flip the fraction. So then I would get 2/1. And if I were to multiply those two together, I would get 2/2, which equals 1. Now I know I found the correct reciprocal. Now, I did say the word flip, but I want you to understand that's the action of finding the reciprocal. That's not actually the reciprocal. So when you are speaking in class, we don't want to say, yeah, you just flip it. It's you find the reciprocal. And yes, I did essentially flip the fraction to find the reciprocal, but we really want you to know that it's the reciprocal is what it is, not just a flip. Okay. So now we have 3/4 times 1/2. And I made a mistake. It's 3/4 times, there we go, 2/1 because I had to use the reciprocal. All right, so now that we're not adding or subtracting fractions, we can actually cross simplify. So I asked myself, can 1 fit into 3? Well, yes, but does that really help us if we're simplifying with 3 and 1? Because 1's already as simplified as it gets, so it's not going to help us. Then I say, can 2 fit into 4? And that question is yes. 2 fits into 4 2 times, and 2 fits into itself once. So now I'm left with 3/2. But this is an improper fraction, and we all know when we go visit our grandparents or we go somewhere nice, we must be proper. So in order to be proper, we ask ourselves, how many times does the denominator fit into the numerator without going over? And that is 1 time. And then we say, okay, what is 3 minus 2? 1. And we keep our denominator, and there you have it. 3 halves written properly as a mixed number is 1 and 1/2. Let's look at one more example. All right, for this example, it's a little harder. It's 5/7 divided by 1/13. Okay, so we have to find the reciprocal. So when I find the reciprocal of 1/13, I know that it would be 13. So I rewrite it as 5/7 times 13 over 1. Am I able to cross simplify? No, because 7's prime, and so I can't break down 7 anymore. And 5 is also prime, and we know 1, we can't do anything. And oh, 13's prime. So we really can't do any kind of simplifying. So we just have to bite the bullet, and we have to multiply across. So 5 times 13 is 65, and 7 times 1 is 7. Now we know that 65 over 7 is not proper. So I must ask myself, how many times does 7 go into 65? And that is 9. Okay, now 7 times 9 is 63, right? So then I have 65 minus 63, and that is 2. So now I'm left with 2 over 7. And the reason I was able to just subtract 3 minus 2 in the previous problem, it's because 2 only went in one time into 3. But since 7 goes in 9 times into 3 and 9 times into 65, I have to actually take 9 times 7 and get 63, and then I'm allowed to subtract. Otherwise, I would have 9 and 58 over 7, which doesn't make sense because then I'd have another improper fraction over here, and then I'd get a number that's much bigger than 9, which wouldn't help us. Okay, hopefully, box this in for you. Hopefully, this made some more sense, and a lot of this was some review for you guys. I want you to try some on your own. Good luck, and keep soaring, Falcons.